All right, guys, so after looking through this survey, it looked like rational expressions was something that we definitely wanted to go over. There were some other things. So depending upon how fast we can get through this and how comfortable you all feel moving forward, we might be able to get a couple more relearn topics in this mix before the end of the school year. So starting out, we're going to talk about rational expressions. So this is something that you guys did right before I got there. So this would have been in like December-ish. This is just a quick like relearn of it. So since you guys have already learned it this year, you should be able to pick it up pretty fast again. But I did create new notes. I don't really know what you used for notes before, but I created my own, and I'm just going to talk through some definitions, some basic procedures, and then give you 4 practice problems, and then I'm going to lead you on your own, and you're going to have some problems to go through on your own. So starting off, we need to define what a rational expression is. So a rational expression is the quotient, so that's when you divide a p and a q. So the quotient of 2 polynomials. So polynomials, we've talked about polynomials a little bit. Polynomials are when you have like multiple variables or anything of that sort. It could just be one variable, just anything that you can graph. So it's the quotient of 2 polynomials, p and q, those are our 2 polynomials, in one or more variables where q cannot equal 0. So why can't q equal 0? So if this was 0, then I'd have something being divided by 0, which is a big no-no. We can't divide anything by 0. So we say that q cannot equal 0. But p can equal 0, right? Because I can do 0 divided by a number. I just can't do a number divided by 0. So some examples of some rational expressions are these guys down here. We have this one here, which is x over x squared plus 2x minus 4. You might look at that and think, how in the world am I ever going to know how to solve that? But don't worry, you can figure it out. We also have this where it's ab squared over c to the 4th. And then another one where it's x cubed minus y cubed over x squared plus y squared. So those are examples of these rational expressions. I have a polynomial divided by another polynomial. And all of these are examples of polynomials. So just keep that in mind as we move forward. So some basic procedures that we need to do when simplifying these rational expressions. So we are going to learn about simplifying them, adding them and subtracting them, and then multiplying and dividing them. So just starting off, I just want to talk about simplifying, and we're going to practice simplifying some before we move forward because we'll have to add another step in there before we can simplify. So basic procedures, when we are solving these rational expressions, the big thing that we're going to do every time is to just divide out the greatest common factor. So greatest common factor of the numerator and the denominator. So if you're asking yourself, well, I don't really know what a factor is. Well, that's things that can multiply together that go into a number. So some factors of 24 would be like 6 and 4 and 2 and 12 and 1 and 24. So numbers, 2 numbers that multiply together to give you that number. This also applies for exponential variables. So if I have x squared, well, how could I get x squared? That's x times x. If I had x cubed, how could I get x cubed? Well, you can do x cubed times x squared times x. You can do x cubed times 1, that sort of thing. So the big thing that I want us to remember, though, when we're doing these is to remember you can only divide out or cancel an expression if it is a factor of the numerator and has to be a factor of the numerator and the denominator. So just keep that in mind as we move forward. That might not make too much sense right now, but it will as we continue to progress through this unit. So for my first example, I stuck with some pretty simple values. So we have 18x to the 4th, y to the 7th, over 24x to the 8th, y to the 4th, z. So I'm first going to start with my numbers. I want to talk about 18 and 24. So what do those two have in common? What is the biggest value that I can take out of both of them? So if we think about some of the factors of 18, there's 1 and 18, 2 and 9, 3 and 6, and that's about it. If I think about 24, I have 1 and 24, 2 and 12, 4 and 6. So if I write all those out, factors of 18, I had 1, 2, 3, 6, 9, and 18. If I think about my factors of 24, I had 1, 2, 3, 4, 6, 8, 12, and 24. So I'm looking for my biggest factors. So the biggest number that goes into both of them. Well, 1 and 2 both go into them. 3 goes into them. 4 goes into 24, but not into 18. 6 looks like it's going to be the biggest factor that I have there. So I'm going to take a 6 out of the top and a 6 out of the bottom. So when I do that, 18 divided by 6 is 3. And then 24 divided by 6 is 8. Oh, I lied. 24 divided by 6 is 4. Sorry. I was looking at 8 when I said that. So then we need to deal with our variables. So if I have 4 x's on top and 8 x's on the bottom, that means I'm going to have more x's on the bottom than on the top. But then I ask myself, how many more? Well, if I think about 4 compared to 8, and I have 8 where I take away 4, I'm going to end up with 4 x's on the bottom because the bottom level has 4 more x's than the top does. So then I'm going to look at my y values, and I have 7 on the top and 4 on the bottom. So there's more on the top, but how many more? Well, that's 3. And then I ask myself about the z's. Well, there's no z's on top, but there's 1 on the bottom. So I'm going to keep that z on the bottom. And this is going to be my final answer. 3y cubed over 4x to the 4th z. So that one was a little bit simpler. It just involved numbers and variables. So we are going to get into some more complicated things where we're going to have actual polynomials, and we're going to have like binomials that are to a certain power. And that's what we're actually going to look at next. So these ones where they're just numbers and variables, they're pretty straightforward. You simplify the numbers and then you go variable by variable and look at which has the more. Is it the top or is it the bottom? And then by how much. So if we look at number 2 here, number 2 says 6 times x plus 4 to the 3rd power times x minus 2 to the 2nd power over 30 x plus 4 squared. So I need to ask myself some things. Can 6 go into 30? And if it can, how many times? So 6 can go into 30 5 times. So if I think about this part, I can cancel some things out here. And on the top, I'm not going to have any more 6's. And on the bottom, I'm going to have 5. Because 5 times 6 gives me 30. So if I take a 6 out of both of them, I'm just left with that 5. And then I'm going to look at these guys where I have this x plus 4 cubed, x minus 2 squared, and x plus 4 squared. And I'm going to ask myself, are there any common things happening? So is there an x plus 4 on the bottom as well? Is there an x minus 2 on the bottom as well? Well, there's x plus 4s on the top and the bottom. So the top has 3, the bottom has 2. So there's more on the top than there are on the bottom, and just by 1. So if I were to cancel these guys out, I'm still going to be left with an x plus 4 on the top. And then I go to my x minus 2's. Well, there are no x minus 2's on the bottom, so I just have x minus 2's on the top. So this is what our final answer is going to look like, actually. I am going to clean this up just a little bit. Put that 5 directly in the middle. But this is our final answer for a problem that looks like that. It's just like the problem that we just did where we analyze what's on the top versus what's on the bottom. What can I simplify? What can I not simplify? These really aren't too bad. It's just a matter of being able to understand what goes where. So I'm going to keep going. So this is where things get a little bit more tricky. When I have a problem such as this, right off the bat, I notice that this is a group and this is a group. So I can't factor, just because there's 3 x's on top and 2 x's on bottom, I can't just go like that. The reason why I could do that up here on these two is because everything was being multiplied. So for both of these two problems up here, like in problem number 1, it was x to the 4th times y to the 7th. And it was x plus 4 cubed times x minus 2 squared. Down here, my things are being added together. So we can't separate addition the same way that we can multiplication. So we're going to have to do something else. And what we're going to do is think about, is there anything that I can factor out of both the top and the bottom? So I'm going to first look at this x cubed plus 3x squared. And I'm going to ask myself, do they have anything in common that I could factor out? Well, they both have x's. The first term has 3, the second term has 2. So I can take up 2 x's and I'll be left with x plus 3. So this is just factoring out the greatest common factor. We practice this a lot, especially when we were doing the quadratics. So that's my top part. That's this top part. I can take out an x squared and I'll be left with x plus 3. So now let's talk about this bottom section. What can I take out of x squared plus 2x to the 4th? So my first term has 2 x's. My second term has 4 x's. So I can take up a maximum of 2 x's. And when I do that, I'm left with 1 plus 2x squared. So if you don't really like the way that that looks, addition, you can kind of swap the places. So I can move these guys. So I could also say I have x squared times 2x squared plus 1. Those two are the exact same thing. Either way you want to write it, you will be correct. So I've dealt with my top, I've dealt with my bottom. So let me just rewrite this guy. So on top, I said I'm going to have x squared times x plus 3. That's that purple one that I factored. And then on bottom, I'm going to have x squared times 1 plus 2x squared. And that's this dark teal that I have over here. So then I ask myself, well, is there anything that I can cancel out? Is there anything that I can make simpler? Well, there's an x squared on the top and an x squared on the bottom. And since this is multiplication happening here, I can cancel these two out. So my final answer that I'm left with is going to be x plus 3 over 1 plus 2x squared. I can't do any more simplification, so that is going to be my final answer there. All right, so for number 4 has a lot going on. So what I'm going to do is I'm going to kind of break things up here. So I'm going to break things up, and I'm going to start by doing breaking up my addition. So I'm going to do this over this, and then this over my denominator, and then this over my denominator. Sorry, that wasn't exactly where I wanted it to be. So I'm going to start with that blue. So I'm going to break everything up, and if I start with that blue, then I have x cubed yz. So that's my first term over that denominator. And then they're all being added, so I'm going to add. And then the next one is that second term, so x y cubed z over my denominator. And then that last term, which is x y z cubed over my denominator. So this makes everything a little bit easier to see, and then it's all broken apart, so then I can individually simplify some things. So if I start with this blue color, if I start with my blue, I'm going to look at my x's. So there's 3 on top and there's 2 on bottom, which means I can take, how many x's is going to be on top? Well, there's going to be 1 left. So for my blue, I'm going to have x. And then I'm going to have it over something. So let's look at what next. So there's 2 y's on bottom, 1 y on top. There's more on bottom than there are on top. And by how much? Well, that's 1. So I'm going to have 1 y on the bottom. And then I look at my z's. There's 1 z on top, 2 z's on the bottom. So I'm going to end up with 1 extra z on the bottom. So that's my blue term simplified. Now I'm going to go to my pink term. So x and x squared. There's more x's on the bottom. And by how much? Just 1. There's 3 y's on top, 2 y's on the bottom. So there's more on top than there are on bottom. And by how much? Just 1 again. And then I look at my z's. So there's 1 on top, 2 on bottom. There's more on the bottom. There's 1 more. So I'm going to put my z there. And then I'm going to look at my last term. So there's 1 on top, 2 on the bottom. So there's more on bottom. There's 1 more on the bottom. Then I look at my y's. So there is 1 on top, 2 on bottom. So there's 1 more y on the bottom. And then I look at my z's. So there's 3 on top, 2 on the bottom. There's 1 more on top than on bottom, so my z is going to go on top. So this would be an acceptable answer where everything is separated out. I am going to show you another way to do this problem. If it gets confusing, that's fine. You can stick to the way that I did it, but I will show you the other way that you can simplify this. So let me just rewrite this guy real quick. So the other option here is to go ahead and do a factoring out kind of a thing. So I look at my x's on the top. I have 3 here, 1, and 1. So the maximum I can take out is 1x. And then I look at my y's. I have 1, 3, and 1. So again, I can only take out 1 y. Then I look at my z's. I have 1, 1, and 3. Max I can take out is 1. So when I factor all that, I end up with x, y, z has been taken out. So I have x squared plus y squared plus z squared. And on the bottom, I still have that x squared, y squared, z squared. So once I get to this point, then I look at, well, I have 1x and then x squared, and 1y and y squared, and 1z and z squared. So I can take away this, and I'm just left with 1x on the bottom. I can take away the y, and I'm left with 1y on the bottom. And I can take away the z, and I'm left with 1z on the bottom. So my final answer there then would be x squared plus y squared plus z squared over xy z. Both of those are acceptable answers. I'll take either one. If you found it simpler to split everything up and simplify it that way, or if you want to do that factor out where you can factor everything out and then simplify it again, either way is fine with me. I just figured I'd show you both ways just so that you could get more practice if you wanted. So those are the 4 types of problems that you're going to see for your practice today. And then we're going to move on to a little bit more of a complicated problem tomorrow. And then we'll go on to adding and subtracting and multiplying and dividing and all of that fun stuff. If you have any questions, please let me know. And you do have 8 problems for your homework today, for your assignment for today. And I will post those as well. Please feel free to ask me any questions if you have them. I don't think this is going to be too bad. I think you guys will do fine since you've already learned it. Let me know.